I was introduced already. I work at the Institute for Production Systems, and I'm currently working on a research project about AI-based quality control together with the IEIT. In the past, we worked at a research. Our experiences were embedded in this presentation. I think we heard it a few times.
Dass sozusagen bei einer humanzentrierten oder menschzentrierten KI eben auch der Kompetenzerwerb wichtig ist. Und deswegen hier nochmal so ein bisschen der grobe Umriss.
So again, where do I hail from? What's my angle? So in this presentation, I wanted to give you one concrete example for the application from a research context that is supposed to motivate you as to think about how can these applications in the production. I will focus on production, generally speaking, and this is only to serve as an example. I mean, this scenario is not generally valid, and we're very much focused on people here. This is not an organizational view, but actually specifically centered on human beings. So what could this interaction look like in terms of quality control? In the beginning, I would like to describe to you the topic of trustworthy AIs, what are relevant normative or regulatory developments in this context. And then I'm going to get to the second example of additive manufacturing, where I try to outline the project and give you an example where I can place an AI clearly, and then a summary what we can learn beyond this for the design of a trustworthy AI. If we look at the scenarios of AI, this is a model by the European Union. This is not my personal opinion, but the expectation is rather that AI could make a contribution to increase the work productivity.
Wird aber auch gesehen, und das haben wir jetzt auch in den vielfältigen Diskussionen sozusagen erfahren.
What we have experienced is that additional challenges come up. ChatGPT is a great example. People have a very strong tendency that the information revealed through such a system, or that is transmitted by such a system, will be trusted because they assume that the machine knows better. And in quality control, of course, I mean, we want to improve the performance, we want to improve the quality. The quality control is supposed to be improved, but this will be awful. So what's the objective from the point of view of smaller companies, but also bigger companies? Those would be basic competencies that need to be gathered.
Projekt beteiligt sind. Gleichzeitig müssen natürlich auch methodische Leitplanken gesetzt werden. Und quasi beide Facetten will ich einmal in diesem Vortrag auch aufgreifen.
So I would like to pick up both aspects in this presentation.
Von insbesondere KMUs etwas genauer.
So if we look into the situation of SMEs, then I can highlight this point, which I just started to speak about. We have the requirement or the challenge that digital competencies, to the extent to which we need it, are not available, and uncertainty which methods need to be applied. The basic requirement is a digital strategy. And in the case of SMEs, what we find in particular at the moment is the situation that they're lacking the knowledge and the digital potentials are simply not there. And also, it's also about the how, and additionally, they are lacking funds and they do not have the capacities. We conducted a survey which found that
Okay, das funktioniert, glaube ich, nicht. Okay. Der Laserpointer?
I think my laser pointer is not working out properly, unfortunately.
Der was mit dem Laserpointer? Kann ich den benutzen? Der was mit dem Laserpointer? Kann ich den benutzen? Ah, okay. Alles klar. Genau, was wir hier sehen, ist im Grunde einfach eine Umfrage, die auch...
So this is a survey which we would like to present to you, which we carried out with SMEs and also bigger companies. So what are the potentials for an application of an AI? And this is an important The interpreter would like to excuse himself because the audio quality is actually very poor and it's very hard to follow the speaker. I will try my very best, though. So for SMEs, especially when it comes to quality control, there's a huge potential because it does not require as much of an effort to integrate these systems. You could integrate a camera system together with an edge computer that enables analytics. This does not require that much effort. The core point of this slide is actually to highlight that from the point of view of SMEs, quality control offers a high potential, which in this survey actually is something that we found. So a trustworthy AI-based quality control, what would this look like? And we would like to motivate SMEs to do so, to employ this technology. From a regulatory and research perspective, we have the following development. So we have a high-level expert group, and we gave them the recommendation as to how ethically and legally you could employ AI. So a recommendation was made where the risk of AI system was supposed to be assessed, and then measures were actually taken as to how this AI was supposed to be used. At the same time, the federal government did pick up this point in their strategy, so a trustworthy AI use as a USP will be integrated in the AI systems developed in Germany. So this recommendation leads to more concrete guidelines. We have the development of the AI certification, IAIS, where an analysis is first carried out and then measures are defined in order to fulfill the risk requirements. I am basing this talk on these guidelines. I will do so sustainably, so I would like to explain it more in detail. So the idea of these guidelines, just as with the overall initiative, is to develop AI programs to high standards and to secure it against risks.
Strukturierten Leitfaden bereitgestellt, wo eine Risikobedarfsanalyse durchgeführt.
So we carried out an analysis of requirements according to different dimensions, which I'm going to explain to you on the following slides. So we have a top-down approach where the risk requirements are determined, and then measures are defined, which will then be reported on. So within the framework of these guidelines, we determined 6 dimensions which need to be looked at independently. One of them is fairness, autonomy and control as one aspect, which boosts the interaction of the user with the system, rather describes it. The system can be overruled, so the decisions, in case there's an inspector in one of the reviews that their assessment is incorrect, that the system can be corrected. Third one is transparency, including requirements as to competencies, but also explanations as to the model's decisions, so people wouldn't just receive a result. Also as a base for the decision of the AI systems.
Dann haben wir das Thema Verlässlichkeit. Dazu gehören sicherlich auch Aspekte wie Robustheit.
I won't dive too much into these details. But what happens if there's an AI in the interference or in the decision-making process when it receives a new data point and it finds that this is not sufficient for the actual, it doesn't have the sufficient knowledge because the data point is too new. Then we have security aspects, which are about, especially, but in particular, the aspect of security of the person, which, generally speaking, is not as relevant. Data protection is another important aspect. To give you a more concrete application context, I have here the scenario from my research project, and the aim is here, within this circle, which explains the project itself, we actually collect the data on the additive manufacturing process. So we have layers that are being printed. That is the kind of process that we're looking at. And within that process, during the ongoing process, we have in situ measurements executed by the system, a thermographic camera in particular, as well as a conventional optical camera. So these data are gathered, but also process data. So now there are certain layers. One layer is produced, then it gets inspected, and it gets assessed by the help of AI-based processes. Process parameters are then adjusted, which might entail a certain resource efficiency if the system works reliable and in a trustworthy manner. About the setup, I mentioned it in the beginning. We have here a system which serves as a center for intelligence. I mean, the center is an edge device which gathers all of the data, which analyzes the data. Then we have a trigger whereby the process itself, per layer, a signal is given whenever a certain layer was produced. So we do not collect too much data via the optical systems. And then we also have the process data that are being gathered, which are then analyzed on the edge device, as I mentioned earlier. And the training of those models is then carried out in the cloud. This is a bit technical, but it is necessary in order to understand the overall setup. Then we have another concrete image here of the manufacturing plant. On the left, we have a spray gun, which is a fairly innovative metallurgical additive manufacturing process. In the middle, we have the switchboard, including the individual components. And on the right, within the framework of the pre-trials, the way we set up the measurements. This is the risk-need analysis for this concrete use case. I mean, I mentioned it earlier on for the quality assessment itself, but also on the logic of the process itself. We look at individual dimensions or facets of those dimensions. That is what we're assessing. And regarding the need for protection, we assess them. In this research project, it was especially the dimension of autonomy and control reliability that we based this on. Security wasn't that important. We rather ignored it because in the room in which we carried out the experiments, there was already a lot of safety. We could lock the doors. There were no people who came in. Data protection wasn't relevant either, since, well, this was a research project and we didn't process any sensitive, personalized data, but in other quality control use cases, this may become relevant. About the topic of fairness, this is another topic which we ignored because this regards the discrimination of minorities, which in quality control does not really play a role. So yeah, there we are. At the core of this project, we try to ensure transparency, which does not just entail, well, explaining the results of the model, but rather also having a certain degree of, well, an increase of competence. And what we found in this research project is that in the projects, also in this case, we have different stakeholders who we got to sit at the same table. So we brought together a data scientist who orchestrates the different layers, and we also have a domain expert who's well familiar with the process and also can also contribute certain quality properties. As I mentioned, the data scientists as well as the IT department who were involved early on in the project, or they're supposed to be in any case. the domain experts. We also added the user who's going to use the system. They also need to be integrated in creating the system, in the design of it, so that the usage of the system is going to be conducive to the overall result. Well, to put it into more specific terms, as opposed to the user in the operations, basic information on the function as well as the results, and the grounds for the results need to be delivered in order to create trust. There needs to be a realistic assessment as to how reliable the system is. And essentially, they need to have the option to intervene if needs be. Again, from the experience of this project, and overall, in my opinion, it is necessary to offer training and further qualification courses for this AI system in order to give a realistic assessment of these systems at the end of the day are going to perform. So as a mock-up, how can you set up such a system or a concept? One important value is that apart from the actual assessment, you provide a confidence, which also allows for a reliability assessment. So can this AI actually assess this data point? Is the data point too new? Are we speaking of an anomaly? Or are these added data? Also, we need an explanation in order to recognize in this area. I mean, in this case, we had an optical system, and basically, the reason, well, in this area, the AI had a very close look and provided a reason for its decision. I mean, this is a human-in-the-loop approach, which actually makes sense in order to enable an intervention by the user. Furthermore, it is important that we consider, just to remember, just to keep in mind how conventional methods are currently employed. And you see that classical machine learning methods are applied here. They overestimate the confidence for unknown data points. And for that, certain confidence values serve as indicators for various phenomena that also make it plausible. Well, at the end of the day, you do need experts to evaluate the suggestions made by the AI, but things may be detected in this case which, through a manual quality control, would have been overlooked. As a result, going beyond this use case, this example, we have the following 4 points. It is about the effective communication in interdisciplinary teams and role-specific training for increased trustworthiness, especially for domain experts in the area of AI. We require we need to pass on the confidence of AI methods, basic skills, realistic ideas to users. We need the implementation of reliable confidence values and explanatory methods. And we need to establish user intervention options for a human-in-the-loop approach if an AI needs to be corrected. Exactly.